Hello and welcome to Cloud Security, Keeping Serverless Data Safe, a panel discussion from Security Boulevard. I'm your host today, Mike Vizard. It's my pleasure to be here, and today we're going to be talking about the rise of serverless computing frameworks and what that means from a security perspective. Our panelists today are Brian Joe, who's a Senior Director for Product Management at Signal Sciences, Shiri Itzvan, Product Manager from WhiteSource, Vikram Varakantam, Head of Products for Lacework, and Fulia Sengil, Senior Solutions Architect for Veracode. Everybody, welcome to the panel.
Thank you.
There's going to be an ebook that goes with this conference, so after you are done listening to this, feel free to download Keeping Serverless Data Safe, an ebook from Security Boulevard. So let's set the stage here a little bit. Serverless computing frameworks have kind of risen in popularity much faster than most people would have thought. Primarily, it's up in the cloud still, but it looks like it's going to be in every cloud you can imagine, and there'll also be some use cases on premise. But what's happening is that developers are sitting there and going, hey, this is awesome because I can reduce the amount of code inside my application. I don't have to write as much code to, for example, run an analytics function when all I need to do that is occasionally. So I just now write something called a function, and I put that into my API call, and I have that process external to my application, and therefore I can get something done a lot faster and much less expensive. And I have a lot of options in terms of what I want to keep inside my code base versus what I want to keep outside my code base. Of course, the thing about this is that all these serverless frameworks are just a friendly API call away. So what could go wrong? So that's where our panelists are going to lead us into this next discussion here. So guys, can we go through the challenges a little bit? And maybe we'll start with Brian and say, I could think of a dozen or more challenges, but when you think about serverless computing frameworks, what becomes the biggest challenge that you're seeing first, Brian?
Yeah, what we see is that just having knowledge and awareness from a developer standpoint is one of the biggest challenges. So with serverless, one of the great things about it is that you don't need to know much about the infrastructure from a development standpoint, but that's also one of the challenges in that you don't know about the infrastructure. So you don't know what type of protection is already there. You don't know what kind of threats are possible. You're reduced a bit to just writing generic functions, as you mentioned, or applications without knowledge or context. That is actually very important to protect yourself from bad actors. So I think to kind of sum that up, really just the level of abstraction is both a help, but it's also a harm.
And do you think that developers are making some assumptions about the security that exists in the cloud that may not actually be true?
I think that's true. I think the offer of serverless is really convenience from a development standpoint. You're able to write functions or parts of your application faster, scale them up more quickly, and not have to spend as much time thinking about how it's going to work together. And so I think that with speed and velocity being the emphasis, it actually makes security even less of a consideration. And so I wouldn't say that it's necessarily false assumptions so much as maybe just not as many assumptions being made or not as much care and design being put into how the system is going to work holistically.
Right. Developers always think it's somebody else's problem. Shiri, what's your sense of what the biggest challenges are, or what should people be looking out for?
Yeah, so I definitely agree with Brian. Basically, you deploy a serverless function, and then it's someone else's problem. You're giving away sort of the responsibility and the control over your actual runtime environment to the cloud provider. So there is a great advantage, right? Patching for the underlying infrastructure is not under your responsibility anymore. But on the other hand, you need to just think about the fact that some of the tools or the methods that you use, like endpoint security, for example, or WAF, which I guess we will talk about, is either not relevant at all or less relevant. And the other thing is that you're now basically only responsible for the data layer. And then your role in, writing secure code and giving the right permission to the functions actually plays a huge role. Similar to traditional application, but here there is a lot more emphasis on that.
Vikram, do you want to add to that anything? It seems to me, at least, that there should be more demand for something that feels at least like a web application firewall in this regard, but it's not clear to me that people understand that that's part of their responsibility, or if there's a whole conversation, especially in the cloud, around shared responsibilities. So do you think that maybe it's not just about the tech, but it's about the process a little bit?
I think I do agree with both Brian and Sherry in terms of how the fundamental difference between serverless and the rest of the computing technologies, where the speed and scale are the forefront of considerations. And when it comes to actually responsibility, when it comes to matrix of what you're responsible for, a lot of it is abstracted away from the developers, right? End of the day, you're writing a business logic and a code, and you're expecting something downstream to be able to pick it up and run securely there. I do see a sense of, further down, the rabbit hole of shared responsibility. You're moving more and more away from the infrastructure to primarily into the code and the logic of the code. And you probably have to, look at two different ways of things, right? One is the tooling required to make sure that what you have written is baseline, appropriately verified from the coding standard point of view. And the second is the environment it's going in, the permissions, the nature of the function configuration, all of this does play a large role in terms of how you secure that function environment. There is applicability in terms of where it runs as with regards to the primarily nature of API security. There is a nature where things like WAF can be useful, but not particularly be the only tool that you have at your disposal to be able to do this right.
All right. And Folia, let's go to you. What's your favorite serverless security challenge these days?
I think I already agree with Sherry, Brian, and Vikram, but also thinking about a little bit on the billing risk, for example. So if you think about, serverless architecture, since the architecture is most likely managed in the infrastructure providers, you don't even think about the, monetary consequences about the security risk. For example, if you are, facing with the DDoS attack, you might be actually losing money because you are using a lot of resources behind the scenes. Which, comes in, for example, creating timeouts in Lambda functions or other best practices in that area, as well as securing, for example, virtual private cloud environments with API gateways are still popular. So it is not just, code and, working without servers. It's actually thinking about the whole concept and also understanding the overview of the infrastructure because of the nature of the cloud native applications. So I think operations part is not visible for the developers from the first run. So that's a big problem in generally. So that's why, for example, practices like not only shifting left, but also shifting up is coming in place.
Yeah. Can you elaborate a little bit? What does shifting up mean? I think people get the idea of shifting left, but what does shifting up mean?
Shifting up is actually based on the, normally traditional operational access roles as well as authorizations are managed by the operating system. However, now with the serverless, it's actually less controllable by the operations or an access model that is in a traditional way. So shift up means, in that sense, you need to actually create controls, part of the container or part of the infrastructure, and embed it to, for example, a Docker image, and manage the configuration that way. So it will be actually not attached to the actual operating system, but it is actually abstracted from operating system, but still visible and configurable from the development and DevSecOps perspective.
All right. Hey, Sherry, let me shift to you for a second here. We talked about APIs briefly here for a second, and I wonder, does APIs kind of fall in the gap between the developer and the security team or the ops team for that matter? And seems to me a big part of this issue is the same issue we've been encountering with APIs across the board. It's not quite clear who's in charge of managing them and securing them. The developer creates them and then they kind of just, I don't know, go away or disappear. So what is the future of API security as it relates to serverless security?
Exactly. So this is a really good point. I think that even traditionally with APIs, even before serverless, there has been like sort of a vague, line there, whether this is something that, the security that is usually, traditionally it's not part of the developers team. Traditionally, there is a separate security team, and there is a separate development team. They maybe even don't know each other, don't speak to each other. So, and this is a very, very big gap because sometimes the security person would say, I mean, in the good case where they actually look at the APIs, they would say to the developers, okay, you have to fix this and that and that. Either send them an email or open, something in a ticketing system, and then the developer would either fix it or not. And it's really hard to close the loop there to make sure that things that the security person actually raised are fixed. I think that nowadays we're shifting more into the not even DevSecOps, but actually having our developers a lot more aware of security, whether if it's in how to write the code or how to secure the code. Potentially it can also reach the good case of like DevSecOps, where we have someone that is an expert in security in each one of the development teams, and you have the right processes in place. But even if we don't get there, and we actually make developers a lot more aware of the security and give them the right tools to be aware of security, I think we solve like half the problem here.
Hey, Brian, do you think the battle isn't so much, is it about securing the serverless framework itself, or is it more about securing the things that the serverless framework is trying to access? For example, I talked to some folks and they're like, if the S3 bucket that you're trying to access data from is compromised, so is the serverless computing framework. So do people understand the relationship between all these different components?
I think it's both. I think you can't have true security without securing both the business logic and runtime as well as the data. And typically with serverless type applications, they're sitting in separate places. So it's a bit of it's hard for me to pick one or the other, but I do think that both of them need to be addressed. And I just want to second Sherry's point earlier about how a lot of this ultimately boils down to I think a lot of the problem would be solved if developers were cognizant of security when they're actually creating the applications and designing their systems, because then security is built in as opposed to having to be found after the fact. I was just at a developer conference last week, actually, and what I found encouraging was the amount of interest that developers have in security companies, or at least security technologies that are more cloud-centric or cloud-native, in the sense that it's not so much, I think there's a stereotype of a developer as just being someone who's too busy and too short-sighted to think about the big picture and to think about security, but I think that's actually not true. I think the reality is that most developers care about their craft, care about security of their applications, but the tools that the industry has been providing them have just been cumbersome and difficult to manage. So I think there's a lot of room and a lot of appetite for developers to actually be more self-sufficient in regards to designing their applications and securing where they're storing things and their overall system design. I think we just collectively can help them by giving them better tools and easier to use solutions.
All right, then. Well, let's move on to our next topic then, since you brought it up. Let's start with Vikram here. But if you think about this for a minute, most of what people seem to be building around serverless computing frameworks is an extension of a microservices-based architecture, and for the most part, is being built with containers. So do you think that the container security and the serverless computing framework security are kind of a natural extension of each other, or are they separate motions, or what will be the relationship between these two platforms that are both coming up at the same time, as it were?
No, great question, Mike. Serverless is I would say, is a more optimized form of containerization of where you run your code. At a fundamental level, serverless and container security start with the same basis of requirements in terms of what kind of logic you're building, what kind of core components you're building from, where are you getting these core components from, do they have any inherent security vulnerabilities? I think all of those are pretty well understood and pretty well needed across both of those domains of both container security and serverless security. Where it fundamentally starts to diverge around is once it gets to the infrastructure component in terms of containers are more persistent. So you need a continuous assessment of your container runtime to be able to really understand how they're performing. Whereas serverless is pretty much an event-driven configuration. It's a point-in-time problem. It comes and goes. But the nature of how you configure or assess the environment it is running in, the permissions they have, the configuration of the files, all of those are very relevant to them. The big difference, however, is kind of, I'm going to try back to what Brian said earlier on, is there's a huge difference in terms of tooling and maturity around how both of these tie together. The traditional way of doing things, or traditional non-cloud native tools, have brought in a lot of cumbersomeness to how developers think about security tooling when it comes to both of these environments. The good part is I think the container security is evolved, is mature when it comes to like a CI/CD pipeline integration, things like that. Serverless is too early. It's still evolving. I think the paradigms that we have learned from a container security world in terms of understanding your code, making sure that you have an appropriate level of risk in your code management, being able to configure the right permissions, all of those are still relevant, but the tooling still is very early when it comes to serverless technologies compared to containers.
All right. Hey, Fulya, let me ask you this then. For many, many years, security people kind of viewed developers as maybe not quite the enemy, but not somebody that they trusted. And yet, as we go forward here in this conversation, you hear people talking more about DevSecOps, and of course, we're only maybe halfway down the road to DevOps as it is today anyway. But do you think that we need to get to some new processes around DevSecOps? What do they look like, and what are the roles or separation of duties between the security people and the developer people?
Mm-hmm. So I believe that DevSecOps is a new trend, of course. Some people also talk about tech DevOps, which is like security actually shifting very left of the development. So that means, for example, if you're trying to build security champions in your organization, you have to actually start as early as possible and actually look at the common mistakes that they are doing even before committing their code. One of the areas of this is, of course, we are still talking about SQL injections, for example, cross-site scripting. Even, we probably talked about it like 20 years ago. So it is a similar concept, and it is similar also, we have new generations of developers, so we need to teach them in that sense. And if you are using different tools as early as possible, and if you make them, encourage people to use them as early as possible, it will be easier to fix and easier in terms of the visibility as well. So, for example, if you are trying to use a library, an open source library, to ease up, the process that you are developing, then you might maybe first check the library itself as a first level of control and see if there's a vulnerability already found in that library, and then maybe decide to a safer version of it. So these kind of practices are common, as well as, learning a little bit more on the operations side, because it's, as you know, it's an infinite cycle of SDLC practices. And, in terms of especially continuous delivery, not only continuous integration, you need to be on top of your game in order to understand what's going on. And also in the operations side, there are additional strategies like for example chaos engineering or similar that will help them to understand what's going on when they're actually deploying, and they need to see a real scenario to test. But if they start very early in development, I think it would be an easy way to repeat the pattern and understand best practices. Since we are still talking like prepared statements for databases or similar, I think it would be best to not punish them, but actually encourage them to apply new practices. And most of the companies are actually thinking about, for example, creating KPIs or metrics that will show them and make them visible to developers so that they understand what is the impact that they are doing in their code when they are first initially commit their code. So that's the way to go, I think. And also it will help them to look, for example, to the scan times, like automated tools that will help them to understand. Because traditionally, as you know, security is seen like a bottleneck in delivery of software. So everybody at the end saying like, oh, we have a security bug, we need to fix it now. So we have to hold the deployment to the production and, maybe spend another 2 weeks to actually fix these issues. But if you are embedded from day one, and if you can actually see these vulnerabilities in your backlog when you are planning your sprints, for example, it might help them, and also it might also educate them in that sense.
Okay. Sherry, let me ask you this. Do you think that security people are going to need to learn how to program, or can I get to this separation where maybe the developers are responsible for implementing the controls, but the controls are defined by the security people and maybe verified by the security people once they're running? So I get to this kind of Ronald Reagan trust but verify model. Or is it going to be just too hard and maybe we need the developer people to become security experts from end to end? How do you see that coming together?
Exactly. So the way I see it is that the security team definitely needs to pose, the guidelines, the processes, and the policies. So a security team can say something like, okay, if we're, for example, the open source dependencies, if there is a high severity security vulnerability defined by the NVD, we don't have a mitigation, we don't have a firewall, then this should not go in production. Okay, so this is like the baseline. Or baseline can be something like, okay, we need to perform, a pen test every once in a while and handle the results, and they will prioritize the results. So they sort of have to put, those guidelines in. And then this is like the CISO responsible for. And then when we look at the developers or DevSecOps or even DevOps, their job is to execute on, those guidelines or those policies. And the way that they will execute will usually be, to automate and code. So things like, for example, we discussed breaking your Jenkins or TeamCity build if there is a high severity security vulnerability. It can be something that they, execute. They wrote the code. They wrote, the script that actually fails the Jenkins build. But it's not their job to decide what the severity level, what happens when the security issue cannot be mitigated. This is something that needs to come from the security team. And I think that definitely we will see, I believe that anyone in the organization will need to write more code. Whether if it's, security teams, but it's also like finance and HR, everyone eventually will need to have someone in the team or work with someone that codes, because that's just our world now. But if we look at, security specifically, then I definitely think that it's a matter of having the right processes in place and automating them. The initial round can be quite expensive in terms of resources, and there's a learning curve. But then eventually, when you have all those processes in place, it actually becomes pretty easy. If we talk about like implementing, DevSecOps or security tools.
Right. Hey, Vikram, let me ask you something. When I talk to security people, a lot of the policies seem to be embedded into some sort of appliance sitting at the network edge. Can I take those policies and apply them to this brave new world of serverless and containers, or will I need new policies? And so by definition, I need different platforms to manage this whole new stack of software, essentially, because I know most security people don't want to write two separate policies, but at the end of the day, maybe they don't have a choice.
I think a great question, Mike. What Sherry was alluding before is everybody today is in the value creation business when it comes to pushing new technologies and new code. And what it also means is that any technologies that you adopt as an organization need to be enablers for that value creation. In that sense, security is becoming everybody's responsibility, all the way from security teams responsible for outcomes to the developers building the code. The traditional tools have been more of a blockers, more of a gates where it's sitting on the edge trying to, prevent something that's written in stone to be able to say which is good or bad. I don't think that will scale with the world of, microservices and containers and serverless security, where things are scaling at a moment's notice and everybody is involved in the process. What I see is the relationship between the security teams and the implementation teams, and more so in terms of the same relationship I see on the product and the engineering side. And ultimately, the security teams are defining the responsibilities, the policies, the outcomes, translating into execution goals. And the engineering teams and the developers or the distributed, value creation teams themselves are kind of assimilating these things and embedding into their workflows and processes and tools. As such, the tools, we see a clear distinction at Lacework is the tools that needs to be built for the cloud native world should be completely different from the tools of the perimeter age, where a lot of things were coded in stone and you had very little to, definition in terms of what you can change there. Now it's very much an iterative process. We have seen all the way in terms of there is security as a responsibility is embedded all the way across the board, communicated through workflows, having a feedback loops across the board. That is what seems to be working well, at least in our customer base, where security becomes everyone's responsibility. The policies are distributed and assimilated as workflows versus cut in stone type of things.
Yeah, I just want to chime in on this one too. I agree with Vikram in the sense that the tooling needs to be different with microservices, cloud native type applications, as well as more legacy, maybe applications that were written in a perimeter-based age. But I think from a practical standpoint, many of our customers struggle because they have both, right? So they'll have one of our customers, for example, in the financial services industry, they have decided to move to microservices for all of their new applications, but it's going to take them 5 to 10 years to transform their entire enterprise into that architecture. But at the same time, the security threats that they're protecting against are continually evolving. So one of the things that we've noticed is just that customers don't want to actually, even though there are two types of tools required and almost like two different mindsets, it's too much of a burden to actually have to manage two sets of policies and two sets of tools. I think that's where we found a lot of success, is where we offer customers a simple way to manage across both types of infrastructures or any kind of infrastructure, in the sense that they, so for example, we can be deployed as an appliance or in an appliance type model. We can also be deployed as a sidecar in a container. We can be deployed as a proxy. So all of those things hook together into the same centralized interface, the same backend, so that decisioning, reporting, notifications, alerts, all of those things get to the right people and can be managed by the centralized security team. Because typically there's not going to be like a DevOps security team and then a legacy security team. There's usually just one security team, and they're setting one set of policies, and they want to manage that separately. Or sorry, they want to manage that all together with the ability to assign roles, permissions, and set baseline standards that applications of all types will need to follow.
Okay. Well, let's go to our next topic then, because it dovetails right into that. So, Brian, let's continue that conversation. We talked a little bit earlier about web application firewalls, but it seems to me, at least, that the take-up of that technology in the monolithic world was somewhat slight. It wasn't like huge numbers, and penetration would suggest that it's less than 20% of the available market. Do you think as we move to serverless computing frameworks and containers, that will change because a lot of this stuff maybe is API driven, or what will change the way we combine our existing technologies with new technologies in some new and interesting way?
All right. I think in regards to your point about the legacy market, I think much of WAF was defined or driven by compliance and regulatory needs. So, for example, PCI 6.6 kind of basically makes anyone who wants PCI compliance have to have a WAF. So I think there's a lot of that type of behavioral patterns that were going on in legacy. But I think in cloud native type applications, there's a little bit less of that type of compliance driven design. And so I think that, you know, our company is a WAF company. I think that we have been looking at how that changes our strategy and how we actually are able to protect applications in the new paradigm. And so one of the things that I think I mentioned earlier is just being able to deploy into any type of infrastructure. So whether it's an appliance or a web server, or maybe a few lines of code that you embed into your application, I think it's really important that any security solution has the ability to be able to do that and protect developers on whether they're using embedded infrastructure or more serverless type infrastructures. Yeah, so I think that flexibility is super key. The other thing that I think has changed is that the threat landscape has changed as well. So typically with more monolithic applications, there's usually just one point of attack. It's the egress, where you're basically facing the public internet, and there's a single entry point into your application. And then any backend services that are called are typically within your private data center and not really at risk behind the firewall. I think in a serverless or container-based model with microservices, a lot of those backend calls are actually now their own APIs or gRPC calls, and they could be exposed to, if your infrastructure is not configured the right way, to similar types of attacks that perhaps we weren't seeing in the past. So I think a good example is something like server-side request forgeries, where attackers pretend to be an internal server, and then they basically hijack other internal servers. I think we've seen that used with some great success in some high-profile breaches recently. And that type of exploit is really something that is, I think, kind of, it's not really new in that the sense that it's been around a long time. However, it is new in the sense that there's a lot more opportunity for that attack to be effective, because so many people are breaking down their monolith into microservices without a full understanding of the infrastructure behind it and how all these new endpoints are being created and potentially exposed to attackers.
Okay. Hey, Folia, let me ask you this question as well, since you're a solutions architect. So when you're building these solutions, are you seeing people trying to put together a mix of old and new technologies? And what does that look like from your perspective?
I think it also really relies on the cloud native providers as well. So, for example, if you are thinking about AWS, they also still have WAF, and you are using, for example, API gateways in order to secure endpoints, which is like still a best practice that everybody considers, even though it's a serverless application or a microservices architecture for APIs. So the reason being is that you can actually manage policies in terms of API key management, for example, or monitoring DDoS attacks, or getting information out of it. So WAF is still a good monitoring, I think, element of the new architectures in that sense. However, it will probably have less functionality or less responsibility in the architecture. So that's actually a good thing, because in old days, as you know, everybody was like, oh, if you put a WAF on it, then you are fine. And most of the applications that are, especially in intranet applications or portals, they consider that it will be safe unless there's a really big breach on the network. So in terms of managing the architecture, the responsibility most likely will be on the cloud providers. However, as you might remember, the Capital One breach a couple of months ago, even though they are using cloud providers, they were still, vulnerable regarding the API credentials, etc. So, and the reason was not, because they are using cloud providers, it was actually normal human error. And it was actually related to the access rules and also the SAM model that they are using. And I think that the modern applications still have the same kind of, for example, structure of different things. And the principle of least privileges is still valid in any way, in the old or in the new architecture. But we also talk about, for example, new concepts like NoSQL databases, like DynamoDB, or we are talking about federated queries like AWS Athena. So these are new, services that are part of the cloud native architectures, and I think it will also help people to understand more on the architecture and use more functionality. Also similar, managing containers like Fargate or similar, that will help people to rely on them more and maybe, configure everything manually. But we still need old architectures as well as new together, and it should be a synergy. And most of the new enterprise customers are also using hybrid models anyway. So they are not only relying on the cloud native, at least not at this point. And they still need to manage local infrastructures as well. So in my opinion, WAF is still a good tool, but the use case will be a little bit different than the old, days, I think.
All right. Hey, Sherry, can you pick up on that theme a little bit in the sense of when I look at serverless frameworks today, the most dominant one is Lambda. It's still early, and that's a proprietary implementation. And you guys specialize a lot in open source. So do you think we're going to see a lot more of these open source serverless computing frameworks? And as such, will I then need to figure out how to secure multiple serverless computing frameworks in multiple clouds? And how might I go about that or think about that? Sherry, are you there?
Sure, I think you might be on mute.
Sorry, I was muted talking to myself. And yeah, so I definitely think that the open source is a challenge here, both in terms of, you will have multiple open source tools to secure your application, but also in terms of like your actual code, whether if it's functions or it's deployed in containers or even in traditional servers, you have a lot of open source code. Okay, so like some of the statistics are that around 8% of the written code today is open source. And this is quite a shocking fact, because this is one of the biggest revolutions in like the few, 10 years in the software world. So it touches all the different aspects of, software, and definitely serverless, because when it comes to serverless, I think that a lot of the existing tools cannot monitor properly serverless functions. So we're seeing some, with white source, there are some other tools in the market that do it, but this is a very big challenge for existing organizations to pick up on. One of the biggest challenges both in open source but also in proprietary code is like dependency scanning and making sure that, you know, you have your current library, the root library, but then maybe it calls, you know, 100 other transitive dependencies along the way. And you need to make that all of them are in fact secure. So we usually recommend using scanning tool, you know, whether it's white source or there are a lot of open source tools that do this quite well as well. So I think this is definitely one of the best practices when speaking about, you know, open source and dependency scanning in the serverless world.
All right, well, let's start moving over then to best practices, guys. So maybe we'll start with Vikram. What's your favorite best practice or your best recommendation for people as they start thinking about serverless frameworks right now and what they should be attempting to solve or at least maybe prevent before it happens?
I think I would recommend that start with an adoption framework in mind in terms of how you adopt serverless across your organization. That means you have the necessary workflows and the tool set built into managing the outcomes of the serverless architectures themselves. At the very minimum, I would recommend that one is understanding in terms of what's going to the serverless environment, in terms of like the code and the quality of the code, the dependencies, things like that that your developers are using to build the serverless environment. Second is the tooling that is you're using to build the serverless environment, where possible, automate a lot of this stuff, right? There's no reason to re-implement stuff. Your CI/CD pipeline can be leveraged for serverless infrastructures as well. The third is more about, very similar to the last question you had, Mike, is understanding the context of serverless and the configuration of serverless is very provider-centric. I think this is where third-party tools like us will greatly simplify your abstraction paradigms, right? The difference between AWS Lambda versus Google Cloud Functions and Azure Cloud Functions is quite different. It's hard for any single organization to keep up with, what's happening in any one of these services. This is where a third-party tool will definitely help you to bring in the, necessary best practices in terms of how these functions are configured and operating. The third is more of an operational domain. Is you got to bring in some element of runtime anomaly detection. That's something these infrastructures operate at scale. We ourselves use serverless on our side. We go from 100 invocation to 100,000 invocations depending upon any event there, and it's impossible for any human to be able to monitor and process the logs and things like this. So runtime anomaly detection baseline really becomes a key requirement from an operations standpoint, and it all dovetails back into do you have an incident response workflow dedicated to a serverless adoption or not?
Brian, what do you want to add to this conversation as well in terms of what you see as best practices that go in on top of this that maybe people aren't thinking about or not paying enough attention to?
Yeah, no, I agree with Vikram. Well, my joking answer was going to be don't do serverless. I think it's a little bit tongue-in-cheek. I think serverless is the shiny new object from a technology standpoint, and I think there are a lot of people out there who just want to try it out and use it because it's new. But I think the reality is it's very different than traditional ways of building software. And it is a great fit for certain types of applications, but not a great fit for more like most applications. So I think being intentional about when to use serverless and how is basically, I agree completely with Vikram's point on that. The other point I'll just also agree with is on runtime defense anomaly detection. I think, yeah, with serverless, the size and scale that you're looking at is they're going to be very elastic and beyond the scale of an analyst. So I think having, and quite frankly, the threats are going to be very fast as well. So if your security isn't fast, then by the time you find out about it, it'll be too late. So I think having something that's at the runtime that you can just turn on and it protects you out of the box, I think that's a really important thing that everyone should be doing. And that gives you at least some runway with which to do more sophisticated analysis later.
All right, Brian might not be getting that holiday card from the AWS Lambda team this year, but we'll see. Fulya, what's your recommendation to folks as they kind of look at this whole space and what should they be thinking about?
I think I don't want to repeat what Vikram and Brian said already. Additional to that, I think it's very important to rethink of your threat modeling and also assess your attack vectors in that sense. So it might be the case that the traditional models that you were thinking about is not there anymore. So in order to understand more on that, there are a couple of additional services that are available in different cloud providers that can assess the the attack vectors in a way that you can actually build a more efficient threat modeling in that area, and then also maybe thinking about, for example, using customized even runtimes for example, sensitive runtime calculations for Lambda or similar. So depending on the architecture, it might be a good, important case if you are trying to do a transformation, especially. You will first start with a good threat modeling strategy, and Mitra already had that kind of metrics as well as a framework that you can assess your risk. I think this is one of the important parts, because as far as it is a cloud native system, it is not only liability on the side of the cloud provider. It's actually your responsibility to look after what you are storing in terms of data, in terms of processes, and in terms of the application itself. And I think, additional to that, it comes with, for example, things like secure vaults, for example, part of storing your credentials for CI/CD systems in a secure way, or using API gateway for key management for API authorization. Things like additional, for example, runtime detection or interactive application security testing, which we normally include, like Node.js applications, and also maybe involving people who are actually testing the business logic of that application as part of the interactive application security testing. So these are all coming in place, but I think the most, maybe forgotten practice would be threat modeling in the first step.
All right, cool. And of course, Sherry, we're coming to you now with your recommendations, and you have the unenviable task of going last, so you have to play Can You Top That?
Yeah, so definitely agree with everyone. A serverless application is comprised of like hundreds of functions. So you, as the security person or the DevSecOps, must have the complete picture, right, in order to understand the potential risk. And then one thing that people need to remember is that their code is actually there, and it reveals, the business processes, some data that could be sensitive. And I think that one of the questions that people need to ask themselves in order to basically evaluate the risk is like, what data is involved in the application, right? What is the value of the data? What are the services that need to access the data? And then based on that, initially plan, the serverless deployments. Maybe, Brian said it, but maybe not all your application will be serverless. Maybe some will be serverless and some will still be in a container or even on premises, depending on which organization you're in. Serverless can substantially increase the number of resources that we act upon, and we basically sort of increase the detection mode here. So it's really important to remember that, and we must, of course, consider like the policies that we discussed that are basically governing the interaction between those hundreds of resources. And I think that here there are some great tools, but some of the tools are also missing an important value that only someone that is within the organization and knows the actual data and knows the actual workflows. So no tools will tell you whether you can mitigate a risk or not in a fully automated way. So this is something that is someone, a user still needs to remember. I think this is like the main point that I would like to add.
All right, cool. All right, well, we're going to move over to some questions, guys. So I'm going to invite everybody who's listening to type in some questions if they're so inclined. But I happen to have a couple just handy as we're sitting here. And it's curious to me, and I'm going to start with Fulia. We didn't really mention encryption all that much. Do you think that the rise of serverless computing frameworks will force people to try to encrypt everything? If you listen to AWS, that's their mantra these days. So is that practical? Is that something we should be doing?
I don't think it is practical in every scenario, to be honest. Reason being, first of all, as I said before, it's also related to the context. So you cannot encrypt everything, and also it will be in, if you are using a cipher, the cipher might be, changed in any way. So we were, in old days, we were talking about different, cipher types that they were secure, even, SHA-1, for example. And now, everybody using, just out of book, some libraries that are actually have vulnerabilities in it. And they use it because they think that encryption will solve everything. To be fair, you need to understand the context, and as far as I can tell, I think it is more important to look at the context, as well as, there are a couple of strategies that you can do around data. For example, you can synthesize the data, especially if you are using cloud-native environments. You can synthesize the test data, definitely. And you can also, look at the anonymization of the data. You can say PII information will not be stored on one, for example, resource. You can manage different strategies around that. You can use NoSQL databases, as well as, some information for read replicas. So the data, securing strategy is not only limited to encryption in any way. And you can also rotate keys, which is, normally best practice, but nobody thinks about it. They just authorize API keys, and then you sit on it over 3-4 years, even though you are not part of the company anymore, for example. This can, create more issues. I mean, encryption is, of course, good, but it also depends on the context and attack vector, what you're talking about.
Right, and of course, somebody can always steal the credentials for the encryption, so it's
exactly.
only as good as the credentials.
Or
right?
some people are just, committing their API keys to a, public repo or something. That happens as well.
Right.
So, yeah.
Vikram, let me ask you something about monitoring as a best practice. Is that something that we should all be doing now regularly? Because it seems like if I look in the monolithic world, people only monitor maybe their most important applications. But if in the microservices world, everything is interdependent with each other, then do I need to have monitoring being a continuous best practice?
Yeah, I think I'll kind of take it into two different ways. One is absolutely, I think the monitoring of, if you look at the monolithic world, traditionally monitoring was an afterthought in terms of how you manage your environments, and primarily done for compliance reasons, to quote Brian a little bit earlier. In the microservices world, monitoring is a continuous model. I think you got to not only just monitor, but you also continuously profile in terms of the impact of the monitoring results across the organization, whether it be threat, whether it be operations context. But end of the day, you're instrumenting to a very ephemeral world, and monitoring is the only thing that will help you to figure out if there was a context change in terms of the operations or in terms of the security. I do kind of want to be very, cognizant of the fact that a lot of the monitoring practices are pre-established in the monolithic world. What I mean by that is traditionally security teams have organized themselves around a tool like SIM in terms of being able to take their workflows from. Whatever the new age monitoring tools you bring into the mix for microservices will need to be able to feed into the SIMs where the team workflows are designed today. I do recommend that, not change that aspect of monitoring, but actually enhance that area of monitoring.
Okay. One other area, Brian, this one will go to you. Do we not do enough testing as it is, or do we need to do more testing as it revolves around serverless computing framework, specifically maybe in the area of unit testing? I don't know.
That's a good question. I think testing, from a development standpoint, more testing is good. I think with regard to serverless in general, what's actually more important is more system-wide testing, since the serverless application is typically single purpose function. So a unit test is really just, it's not going to tell you all that much. But if you can do an end-to-end system test of sorts, or a scale test or a load test, I think that helps you understand the impact of more important things that are more relevant in the serverless world, like how does it scale, how does it fail over, how does it handle conflict with database read write, and things like that. So I think testing is important, and I think it's definitely just testing with a larger system scope in mind is definitely an area that can probably improve. From a security standpoint, though, I think sort of preemptive testing, scanning of applications, I think how that is evolving is that I think that's getting smaller and more agile. So just like applications, monolithic applications are being decomposed into smaller microservices, I think the same is true for application code, in the sense that typically when you run a scan, you wait till the application is completely written, and then you scan it, and then you come up with a list of everything that's wrong with it. But I think what we're seeing in the market is that applications, actually things like pull requests, so incremental changes to the application, are actually a good place to be doing some level of testing as well, because that actually aligns a lot of incentives. It aligns the developer who can no longer push their code to production or into the mainline branch because their incremental pull request didn't meet some sort of security test. I think overall it has a similar effect to something like pair programming, where you build quality into the actual CI/CD process and it results in better outcomes. So I think from both a performance and system design perspective, testing can improve, and I think from security perspective, testing is just getting faster.
All right, cool. Sherry, your last question is going to go to you. And then maybe it's just me and I don't understand how serverless computing frameworks work, but in my experience, everything revolves around a log, but there's no log in the serverless computing framework. So what exactly am I looking for or monitoring or trying to figure out that's indicative of a compromise?
So yeah, so first of all, there is a log. Like for example, of course, one of the things that you can get in AWS are various tools that will, let you know what happened with the function, whether it was invoked, what was the amount of CPU in the memory, what is the number of invocation. All sort of that stuff is definitely covered. I think that we're looking more for usage metrics to understand whether something is going wrong or right, other than, the traditional log. Of course, even if we're working with function, it's still our job to make sure that there are logs in terms of like developers. If we write a function, we need to make sure that in terms of the application wise, it does consist of logs, and also various tools that can definitely help with, both the traditional like monitoring, but also securing the functions better.
All right, great. Hey guys, thanks for sharing your time and expertise today. That was awesome. I also want to give a shout out to our winners from the people who are getting the gift card. They are Sandra Hick, Philippe DeWolf, and Min Z, I think. And with that, everybody, thanks for spending some time with us, and it's much appreciated. And good luck in your future security endeavors.
Thank you very much.
Having us.
Thank you.